Okay, in the next series of videos, we're going to tackle some of the hyperbolic integral problems. We thought perhaps first we would stop and review some basic identities. Some of these we outlined or actually derived in our introduction to hyperbolic functions. But let's just stop and take a look at them, because what we have written down here, these we will put to use when we start working with some of the hyperbolic integrals. And remember our basic definition: the hyperbolic cosine squared minus the hyperbolic sine squared equals 1. And hyperbolic cosine of x plus the hyperbolic sine of x, that's e to the plus x. If I take the difference between these two, it gives me e to the minus x. And the hyperbolic secant squared, that's equal to 1 minus the hyperbolic tangent squared. The hyperbolic cosecant squared, that's equal to the hyperbolic cotangent squared minus 1. And again, in our introductory video, we derived this relation here: the hyperbolic sine of 2x is equal to 2 times the hyperbolic sine of x times the hyperbolic cosine of x. That's completely equal to its trig counterpart. And for the hyperbolic cosine of 2x, there's several different ways to express that. It could be the hyperbolic cosine squared plus the hyperbolic sine squared, or it could be 1 plus 2 times the hyperbolic sine squared, or it could be 2 times the hyperbolic cosine squared minus 1. And for the hyperbolic cosine squared of x, that's 1/2 the hyperbolic cosine of 2x plus 1. The hyperbolic sine squared of x is very similar, except we have minus 1. And remember some of the basic derivatives here. The derivative of the hyperbolic sine of x is the hyperbolic cosine of x, completely equal to its trig counterpart. But here, the derivative of the hyperbolic cosine of x is plus the hyperbolic sine of x. And the derivative of the hyperbolic secant of x, that's minus the hyperbolic secant of x times the hyperbolic tangent of x. The hyperbolic tangent of x, that's the hyperbolic secant squared, completely identical to its trig counterpart. We derived this relation in a previous video using the basic definition here. And then finally we have the derivative of the hyperbolic cosecant of x is minus the hyperbolic cosecant times the hyperbolic cotangent. And finally, the derivative of the hyperbolic cotangent is minus the hyperbolic secant squared of x. And we'll make use of these with some of the hyperbolic integrals that we deal with, and also later on with some of the integrals we'll try to solve them using a hyperbolic substitution instead of a trigonometric substitution. So make some notes of them, become familiar with them, because in the future videos here we'll put them to use.